Welcome everyone. Today I will derive the formula for taking the derivative of x raised to the power of n, where n is a rational number. So the formula that I want to derive is if we have x raised to the power of n and we are taking this derivative with respect to x, then this is equal to n times x raised to the power of n minus 1. So let's get started. And to start, I will actually write x raised to the power of n one more time, and I will represent it using the number e, which is just a number like pi, and I think e is approximately equal to 2.7, something like that. It goes forever. Just like pi, it is an irrational number. So the way I will do it is I will have e, and we will have it raised to the power of n times the natural logarithm of x. You might be saying, how is this equal? How are these two equal? Well, this is not the topic of this video. This is not the focus, but we can go over these. So if you don't know how these are equal, just trust me that they are equal. And as I said, we can do a video about this. So now, if this is correct, we can take the derivative of both sides with respect to x. So let's do that. If we take the derivative of both sides with respect to x, as you can see, the left side is what we are interested in. So if we can compute the right side, then we will have a formula for the derivative of x raised to the power of n with respect to x. So how can we compute this derivative on the right? And the way I want to do it is I will first use the chain rule to break it into two derivatives, which will tell us this: take the derivative of e raised to the power of n times ln x with respect to n times ln x, and I'm going to put a parenthesis here. Then we will multiply it with the derivative of n times ln x with respect to x. Now, how did we get here? This is the chain rule. Great. So let's see what happens. What is the derivative of, what is this part? What is the first derivative? Well, you probably know that. And if you haven't already, if you don't know this, you will be surprised, I think. But the derivative of e raised to the power of x with respect to x is equal to e raised to the power of x. I think it is very nice. And if you see, instead of x here, we just have a product. So the only difference will be, instead of x, we will write n ln x. Just like that. And I will erase this part, this blue ink as well. Oops, what am I doing? All right. It looks good enough. So the first derivative gives us e raised to the power of n times ln x. And what is the second derivative? Well, what we need to notice first is that n here is a constant, so we can just take it out of the derivative. Now we have the derivative of, well, actually, let me write it here. We just have the derivative of ln x with respect to x. And this is equal to 1 over x. And if you guys want, I can prove this in another video, but for now, we will just take this to be true. And perhaps you know the proof of it, and in that case, you should probably be okay with taking this to be true, which it is. So I just write it here, 1 over x. And now, this is the final part. We said at the beginning that e raised to the power of ln n times ln x is equal to x raised to the power of n times n 1 over x. Now, I think you guys are seeing what we're going with this. What can we say about 1 over x? Well, it is just x raised to the power of negative 1 And now we can add, since the bases are the same, we can add the exponents in case of a multiplication, which is the case. So we have x raised to the power of n minus 1 times n. A more preferred way of writing this is n times x raised to the power of n minus 1. So this is it, yeah. Notice that on the left we have the derivative that we were interested in, and on the right we have the familiar formula that we hope to prove. I hope that this video was helpful. If you have any comments, please write them in the comment section. As I said, I use a lot of rules like the chain rule or the derivative of this, the derivative of that. If you guys want me to make videos about them, please mention them in the comment section and I will make videos about them. But this is it for this video. See you again, and until then, take care.